Good morning, grade 10s. I trust that you're well and enjoying the online learning channel. So to this point, you have covered data handling, and I trust that all is in order there. I hope that you have done all the exercises, put on Google Classroom, marked your work, and have a good understanding of data handling. On Tuesday, you would have started with measurement. And the first two lessons were basically revision of grade 9 concepts. And you came across concepts like surface area, volume, cylinders, prisms, triangular prisms, rectangular prisms. So when you watched all those videos, it was just a recap, a little different from me sitting here and talking about them. I thought looking at different videos would give you a better understanding, as it was just revision of concepts. Today's lesson focuses on 3D shapes, three-dimensional shapes, but my focus is more on a concept called scale factors. Some of you may be familiar with it, and if you are, in today's lesson might be a bit more easy for you to understand. When we talk about scale factors, what are we referring to? So scale factors simply means increasing the size of a shape, if you want to look at it as a simple explanation. It is a number which scales or multiplies some quantity. Now, let's go back to an example. A basic example of a rectangular prism as drawn in this diagram. And I have the surface area worked out and the volume worked out. So question A is asking to calculate the surface area and volume of this prism. And if you go back to the previous two lessons, you would know surface area is the sum of all the areas of the three-dimensional shape of all the faces. And you can see there are basically 6 rectangles there, of which you have a pair of each type. And that's why it is multiplied by 2, hence your surface area is 136 centimeters squared. But I'm not going to go into this now. You have done this in the first 2 lessons of measurement. Volume is the area of your base times the height by which it's projected. And in this case, it was 8 times 3 times 4, because you have the same shape on either side. They are identical, and it's projected by 4 centimeters there. And your volume unit is cubic meters, and in this case, it is cubic centimeters. Okay, so that was just a recap, a quick recap of what was covered in lesson 1 and 2 on measurement. Now, let's look at B. Calculate the surface area and volume of the same prism if the length, breadth, and height are multiplied by a scale factor of 5. Now there is this important word. What does that mean? When I started, I said to you, when you look at scale factors, it means increasing the size of a shape. It is a number which scales or multiplies a quantity. So that number 5 is the number that's going to scale the shape. In other words, every dimension, length, breadth, and width, would be multiplied by 5, as indicated here. Okay, so let's work out the solution. Calculate the surface area and volume of the prism. So let's start with surface area. Surface area is, there are 6 surfaces. We are assuming it is a solid prism. It's not opened at the top. It would have stated otherwise. Let's work it out. So if you take the original dimensions, all you're doing is multiplying each dimension by 5. That's basically what you're doing. So if you look at this one, so it will be 2 times. 2 represents the number of rectangles with the same measurements. The 8, there's the 8 here, so the 8 was multiplied by 5. The 3 is multiplied by 5. Okay, then you're going to add it to the second pair of rectangles, which is 2 times 8 times 5 times 4 times 5. You're going to add it to the third pair, which is 2, 3 times 5, 4 times 5. Okay, and if you work all this out, it would be 15 times 40 times 2, that'll be 1,200, plus 40 times 20, it'll be 800 times 2, which would be 1,600, plus 15 times 20 times 2 will be 600. And in total, you have 3,400 centimeters squared. Okay, so as you can see, let's compare the original to the new. So the scale factor of 5, all of the sides were multiplied by that number, 5. Volume, again, we will take the original dimensions, which was 8 times 3 times 4, and we are going to multiply each of those dimensions by 5. So that will be, so it was 8 times 3 times 3 times 3, 4 times 3. And that gave you 24 times 9 times 12, 12,000 cubic centimeters. Okay, now what is the point of this? Now we're going to do a little comparison here. So I'm going to compare the new surface area to the old surface area. I'm just going to work over here. So new surface area divided by old surface area. So that's the first comparison. When you look at your new surface area, your value is 3,400 divided by 136. And that gives you, work it out quickly, 25. Now, a scale factor of 5. So let's rewrite 25 as a base 5, which will be 5 squared. Now let's compare the new volume divided by the old volume. And that is 12,000 cubic centimeters divided by 96 cubic centimeters. And 12,000 divided by 96 is 125. Again, let's represent it as a base 5. Right, so let's look here. Interesting. The surface area, so this, what does this value represent? This value is telling us the number by which the surface area changed or multiplied by, and this is telling us what the volume changed by. So this 5 cubed and 5 squared is an important value. So it changed by 5 squared, it changed by 5 cubed. Now, instead of doing all of this calculation, it's quite simple actually if you recall this here. Now I'm going to show you how we use the 5 squared. So let's take the old area, the old surface area. As we looked here, we saw that the change is 5 squared. So if I take my old area, which is 136, and if I multiply it by 5 squared, what will I get? Will I get the same answer? Let's check. So we go old area, which is 136 times 25. What do you get? 3,400 cubic centimeters. And if you go back to our solution, there's 3,400 centimeters squared. Let's do the same with the volume. We take the old volume. So this is the new surface area. The new volume would be the old, that's the old surface area. So it's old volume times 5 cubed. Because as we worked out here, the change is 5 cubed. And the old volume was 96 times 5 cubed. And that will give us 96 times 125, gives us 12,000 cubic centimeters, which was what we had when we did this. Okay, so in summary, I want to take you to the table. I've put this up for you on Google Classroom, this page of notes here. Now you don't have to do it the second way, according to the scale factor. You don't have to. You can go the longer way as long as you understand what scale factor represents. But if you do remember this, it actually saves you time. Now let's look at the effect a scale factor has on surface area and volume. So I'll just go through a few of these points. As I said, it is typed for you and put on Google Classrooms. If the length, breadth and height is multiplied by a factor of k. So what does that mean? Your length, so let's go to this example. Our length, breadth and height is multiplied by a factor of k, and k in this case is 5. What happens? The surface area increases by a factor of k squared. True. You worked out k is 5. Your surface area increased by 5 squared. So therefore, we took the old surface area and we multiplied it by 5 squared. Hence, we got 3,400 centimeters squared. If the effect on volume, if all 3 dimensions are multiplied by the scale factor, the volume increases by k cubed. And as we saw here, the volume increased by k cubed. We proved this in the previous calculation there. So this is a nice way to remember it. As I said, if you don't remember it, it's fine, but it's a nice summary of the effect a scale factor has. Now remember, all of the dimensions do not have to be affected or multiplied by a scale factor. The question would state it. If the length or the breadth or the height, that means one dimension changed. So the volume increases by k. So in the previous example, if only the length, for example, changed or was multiplied by 5, then your old volume would be multiplied by 5. If 2 of the dimensions are multiplied by the scale factor of k, then your volume will increase by k squared. And as we have shown, if all 3 dimensions are multiplied by a factor of k, the volume increased by a factor of k cubed. Okay, so that's a rectangular prism. I'm going to do an example with the cylinder now. So we move on to the cylinder. And let's look at what effect the scale factor has on a cylinder. So let's look at the cylinder quickly. So as we did just now, the surface area and volume of the cylinder is worked out here. Remember again, you have the curved surface for the cylinder, and the question stated that it was closed, so that means you have 2 circles. Hence you had 2 pi r squared. Area of circle 1, area of circle 2, they are congruent, so it would be the same value. 2 pi r h represents the curved surface. Now let's calculate the surface area and volume of the same cylinder if the radius and the height, so both dimensions, are multiplied by a scale factor of 3. In general, we call the scale factor k. In this case, the scale factor is 3. So let's take the surface area. We can take the answers from here, the values from here. So surface area is 2 pi r squared plus 2 pi r h. So you're basically taking this dimension and you're multiplying it by 3. So it would be 2 pi times 4 times 3 squared plus 2 pi times 4 times 3, both radius and height, so you have to multiply the 3 to both. And your h, yes, all covered, and that is equal to 280 pi plus 432 pi. That is equal to 720 pi and centimeters squared. You remember, you don't have to convert the pi. You can leave your answer in terms of pi, unless otherwise stated. Now, volume. Let's work out the new volume. So the new volume is taking the previous dimensions up there. So it's pi r squared h. So remember, your base is your circle. It's projected. You have congruent circles by that height. So you have pi 4 times 3 squared, 6 times 3 squared. That is equal to, so if you go squared, that's 144. And then if you work this out quickly, 2592 pi, and remember, centimeter cubed. That is centimeter squared. Okay, now let's compare. New surface area divided by old surface area. So your new surface area is 720 pi divided by your old surface area is 80 pi. And that gives you 720, that will be 9. Now remember, our scale factor is 3, so let's represent 9 as base 3. Let's do the same for the volume. New volume divided by old volume, that's equal to 2592 divided by 96, and that gives you, so that's 2592 pi divided by 96 pi. Remember, pi is still part of the answer, is equal to 27, and we represent it as base 3. That's 3 squared and that's 3 cubed. So straight away we can already see the effect of the cylinder. So surface area and volume of the cylinder. If the radius and height changes, the surface area is increased by k squared. There we go. K squared. If the radius and height changes, the volume is increased by a factor of 3 cubed. There we go. And similarly, we can do the same thing where we take the old area, we multiply it by 3 squared, we will get the same answer. If we take the old volume and we multiply it by 3 cubed, we will get this answer. So the table again helps if you remember the basic rules about scale factors. And that's it for today, grade 10s, scale factors. There is an exercise for you. I have put the instructions on Google Classroom under the work schedule for today. Okay, please do the work, enjoy, and we'll see you soon.